Welcome to the third lesson on ICT systems. In this part, we will discuss wireless networks. There are different types of wireless networks, but the commonality between them is that each of them transmits data over the air. A wireless network can be a mobile network, a GPS network, a casting network, a Wi-Fi network, a low-power network, or a mesh network, among others. Let's go through the generations of mobile networks. The first generation was an analog system that could only transmit voices. The second generation, also known as 2G, was the first digital mobile system that could send text messages as well as digital voices. After the second generation, the 2.5G was developed. It can transmit small packets of data in addition to text messages and voice calls. It was the predecessor of the third generation and uses GPRS or edge systems. It is still in use in some regions. The third generation, also known as 3G, is the first IP-based mobile network. It can provide internet services at speeds of up to 3 megabits per second. It is still in use today. The fourth generation offers the first broadband internet among mobile networks. Its speed can reach 20 or 30 megabits per second. Otherwise, it offers no innovation compared to 3G. The next generation worth mentioning is LTE technology. LTE stands for long-term evolution. It can provide broadband internet up to 100 megabits per second and even voice over LTE service. And finally, our last technology is 5G, which holds many challenges for the future. The speed of 5G is up to 40 times faster than LTE. 5G is being developed to serve a huge amount of smart devices. The GPS is a satellite-based radio navigation system that provides geolocation and timing information to a GPS receiver anywhere on Earth where there is a clear line of sight to 4 or more GPS satellites. The GPS requires no data transmission from the user and operates independently of any telephone or internet reception. Wi-Fi is a wireless networking protocol based on the IEEE 802.11 standard, commonly used for local device networking and internet access that allows nearby digital devices to exchange data via radio waves. It is the most widely used computer network in the world, used in home and small office networks worldwide to connect desktop and laptop computers, tablets, smartphones, smart TVs, printers, and smart speakers. Wi-Fi's wavebands have relatively high absorption and work best when there is line of sight. Many common obstacles, such as walls, pillars, household appliances, and others, can greatly reduce range. But this also helps minimize interference between different networks in crowded environments. WiMAX is a family of broadband wireless communication standards based on the IEEE 802.16 set of standards. It is similar to long-range Wi-Fi, but it allows usage at much greater distances. WiMAX can provide internet access at home or mobile across entire cities or countries. WiMAX is suitable for the following potential applications: providing portable mobile broadband connections in cities and countries, providing a wireless alternative to cable and DSL for the last mile of broadband access, provision of data telecommunications such as VoIP and IPTV services, providing internet connectivity as part of a business continuity plan, and smart grids and metering solutions. Our next category is the low-power wide area network. It is typically used for IoT. We can distinguish between cellular-based and non-cellular-based LPWANs. As mentioned earlier, LPWANs are mostly used in IoT applications. This can be remote building maintenance or control and optimization, human tracking, smart metering, natural disaster prediction, smart infrastructure, smart logistics, smart parking, smart traffic management, smart agriculture, and many others. Cellular LPWANs operate on licensed frequencies. One of these technologies is Extended Coverage GSM for IoT, or NB-IoT or LTE for machines. Let's take a closer look at them. The Extended Coverage GSM is based on the GPRS or Edge network. An older GSM network can be converted to EC-GSM with a simple firmware upgrade. It is also backward and forward compatible with 2G, 3G and 4G systems. EC-GSM runs with low power consumption and can cover very wide areas. LTE for machinery is a very novel technology that runs on LTE network and is mainly used for machinery communication. It is compatible with 2G, 3G and 4G systems and uses their security features. It also has very low power consumption. NB-IoT is an IP-based narrowband technology that enables a wide range of mobile devices and services. NB-IoT particularly focuses on indoor coverage, low cost, low battery life, and high density connectivity. NB-IoT uses the LTE standard but limits bandwidth to a single narrowband of 180 kHz. It provides half-duplex communication between devices. Our next category is the license-free one. As you can see, a lot more technologies belong here. These are LoRa, Sigfox, Waveless, Telensa, N-Wave, Bluetooth, and IQRF. Let's take a look at these in detail. The word LoRa stands for Long Range Radio Technology, developed by LoRa aliens. It uses chirp spread spectrum radio modulation. It provides fast transmission of small packets over long distances. LoRa chips cost a few dollars. Gateways cost about $200. One gateway can serve up to 50 end devices at once. LoRa-based network is defined by the LoRaWAN standard. In a LoRaWAN network, end devices can't talk to each other. It means the end devices are organized in a star topology. LoRa uses three frequencies to transmit data, with or without a receipt. The network topology of a LoRaWAN is seen in this picture. You can see that the end devices are organized in a star topology and can connect to one or more gateways. Gateways communicate with the network server. Network server relay data to an application server. The use cases are similar to other IoT technologies. We can use LoRa for controlling, monitoring, observing, smart systems, and many others. Sigfox uses ultra-narrowband modulation technology. It doesn't send packets, but short messages. Sigfox offers low power consumption and low cost with large capacity. Like its predecessors, it operates on license-free frequencies. Sigfox can send up to 12 bytes in a message at a rate of 600 bits per second. It can also send 140 messages per day. This number can vary depending on the subscription. The topology of Sigfox is very similar to the topology of LoRa. There are end devices, gateways, and servers in a network. Sigfox can also be used in a variety of IoT applications. Our next license-free technology is Bluetooth. Bluetooth is a short-range radio technology that operates at 2.4 GHz ISM band. It can cover a range of 50 to 250 meters. It offers both simplex and half-duplex communication. There are two main core stacks in Bluetooth. The first is the older one, called Bluetooth Classic, and the second is Bluetooth Low Energy. For us, low energy is more interesting. We can divide the low energy stack into three parts. The lower layers are called the controller, while the upper layers are called the host. The controller and the host are connected through the host control interface. In this picture you can see the channel distribution. There are 40 channels in total, of which 37 are data channels and 3 are advertising channels. Bluetooth can work in different topologies. When 2 or more devices are connected, this is called pairing. Bluetooth can also operate in broadcasting mode using the advertising channels. In this mode, there is no physical connection between the devices. Finally, in 2017, Bluetooth SIG introduced mesh capability. Since then, Bluetooth offers mesh topology, which is a great advantage for short-range communication. A Bluetooth network is called a piconet. A piconet may contain one master device and up to 7 active slave devices. However, there can also be up to 255 waiting slaves. Connected piconets form a scatternet. The latest Bluetooth standard is Bluetooth 5, which is the major version. There are newer subversions, namely 5.1 and 5.2. Bluetooth 5 offers 2 times better data rate, 4 times greater distances, 8 times greater bandwidth, and a mesh capability. A Bluetooth mesh network offers a many-to-many connection. This technology uses flooding, publish-subscribe, and relaying algorithms in order to enable the mesh capability. Bluetooth applications are very widely used. It can be used in retail, home applications, healthcare, wearable devices, automotive electronics, industrial solutions, and many others. And finally, our last wireless technology is the IQRF. IQRF is a wireless technology specifically designed for low-power mesh networks. It offers both point-to-point and many-to-many topology. IQRF has its own operating system. It operates at low power and low data rate. IQRF can serve 65 end devices at a time. Like its predecessors, it also uses free frequencies. In an IQRF architecture, the end nodes can form a mesh topology. They communicate with gateways, and the gateways communicate with servers. A gateway can be an official device or an open source system, such as a Raspberry Pi. Gateways can use multiple technologies to communicate with servers. IQRF can be used in control, smart metering, monitoring, observation, and many other IoT applications. Thank you for your attention.